Friends, very good morning to everyone. Today we are going to discuss about the preparation of alkanes. Before going to the preparation, let us know something about alkanes. Alkanes are also named as paraffins, organic compounds which contain the carbon and hydrogen atoms and which are saturated are alkanes. Are saturated hydrocarbons are alkanes. They have a general formula CnH2n plus 2, where N indicates the number of atoms. They can be classified as chain alkanes, which are normal alkanes, the branched alkanes. These are the isomers of chain alkanes, cycloalkanes, the alkanes which are cyclically linked. Though alkanes are of not much use as reagents or reactants, but they are of enormous utility as the source of energy. The coal gases we use, which are produced by destructive distillation of coal, is one of the good sources of energy. The liquid petroleum gas, the compressed natural gas CNG, the kerosene oil are the general fuels used for the household purpose and also finds its use in the automobile industry. We can see the CNG run automobiles today. Though kerosene oil is less used, but liquid petroleum gas is the major source of energy in the household preparations, in the household cooking. As this has enormous utility as the source of fuel or the source of energy, the alkanes finds importance for its preparation. Though alkanes are obtained from the fossil fuel, and the fossil fuel is getting exhausted day by day. Hence, we need to prepare the alkanes or the alkanes of our choice, which may not be able to be obtained from the natural fossil fuels, can be prepared in the laboratory. That's why it finds importance in preparation of alkanes. Alkanes can be prepared by n number of methods. One of the most utilized method is catalytic reduction of unsaturated compounds like alkenes and alkynes. As the name indicates, we use a catalyst for reduction of unsaturation present in the alkenes and alkynes. The alkene, the simplest form, the ethene, when we treat with hydrogen gas in the presence of a catalyst like nickel, platinum or palladium in the finely divided form, we use in the finely divided form because it increases the surface area. When we heat it, we get corresponding alkane, that is ethane. The hydrogen gas is passed through the alkene or alkyne in the presence of the catalyst like nickel, platinum and palladium in finely divided form. When we divide it finely, it increases the surface area. When it increases the surface area, it can have more interaction with the hydrogen. The metal which we use as the catalyst, it absorbs the hydrogen gas on its surface and activates the hydrogen bond, and it helps for the addition of hydrogen bond across the carbon-carbon double bond. The unique feature of this reaction is that The catalyst which we use, the metal, is in solid form. The hydrogen, the reactant, is in gaseous form. The alkene, the substrate, is in liquid form. All these are made to react to give rise to an alkane. It is an example for heterogeneous catalysis because the reactant, substrate, and the catalyst are all in three different phases. And for this, we use a special reactors which are called as hydrogenators. Here, this is the vessel in which we keep our vessel, and this is heated, and the hydrogen gas is pumped into this container, and it is closed, and the pressure, what is the pressure of hydrogen gas, is measured by the machine, and it gives with 3 to 5 or 4 to 6 atmospheric pressure we can maintain, and this system is electrically heated, and thus the reaction is made to occur. This is a special apparatus which we use for hydrogenation. Another method of preparation is hydrolysis of Grignard's reagent. Grignard's reagent, the simplest example is methyl magnesium bromide. When it is hydrolyzed, the methyl group is attached to the magnesium. Magnesium is more electron positive. That's why it donates the electrons to the carbon and making it electron rich species. The nucleophilic center of methyl magnesium bromide is carbon, and the electron deficient center is magnesium. The OH minus combines with the magnesium, and the CH3 minus electron rich carbon combines with the electron deficient hydrogen, and it gives rise to methane and magnesium hydroxy bromide. How to prepare this Grignard's reagent? Victor Grignard prepared this Grignard's reagent for the first time. For its work, he has got the Nobel Prize in the year 1912. The Grignard's reagent is named after the inventor. The methyl bromide was treated with magnesium in the presence of a dry solvent like ether. It gives rise to methyl magnesium bromide. The magnesium reacts with methyl bromide. When we heat it, the methyl bromide undergoes homolytic cleavage. Homolytic cleavage means breaking of the bond by equal sharing of electrons. One electron which is taken by bromine, it gives bromine radical. Another electron is taken by methyl group and it gives methyl radical. As methyl radical and bromine radical both are electron deficient, as they are electron deficient, both are unstable. That's why to make it stable, one of the electrons from the magnesium is given to bromine and it gives rise to a methyl radical along with the magnesium bromide radical. The methyl radical which is formed reacts again with magnesium bromide, and both are electron deficient, both are in need of one electron. That's why they combine together to give rise to methyl magnesium bromide. The methyl magnesium bromide is used as the starting material, and after its hydrolysis we get methane. This is the another method of preparation of alkanes. In the first method, where we do the hydrogenation of alkenes has its own limitation, we require special apparatus. That's why another alternative method has been developed. Wood's reaction is another method of preparation of alkanes. The Grignard's utilized the Grignard's reagent and hydrolyzed it. That is a organometallic compound has been used. That's why Woods replaced the magnesium by sodium, another metal, and treated with methyl bromide. When magnesium was treated with methyl bromide, he got methyl magnesium bromide. But here we did not got that. When the reaction was carried out in dry condition using dry ether, we get an higher alkane and sodium bromide. Though the metal is used, but it follows a different mechanism. Methyl bromide reacts, 1 mole of methyl bromide reacts with 2 moles of sodium. The sodium in the polar solvent get polarized and it gives rise to methyl sodium and sodium bromide. The methyl sodium is a metal. It is more electron richer than carbon. That's why it donates its electrons to the carbon, and that's the carbon in sodium, methyl sodium will be electron rich. As the electrons are donated by the sodium becomes electron deficient. This methyl sodium reacts with methyl bromide. The bromine is electronegative, that's why this becomes polarized and the bromine gains excess electron, which is denoted by delta minus. The methyl carbon is delta positive as it is electron deficient, and we know that unlike poles attract each other. The electron rich methyl carbon combines with the electron deficient methyl carbon. The electron-rich bromide ion combines with the electron-deficient sodium and it gives rise to higher alkane, the ethane, along with sodium bromide. And thus way, Wood's reaction has been utilized to prepare higher alkanes. The simplest method for the preparation is decarboxylation of carboxylic acids. We take acetic acid and heat it strongly in the presence of calcium oxide at 630 degree Kelvin, and it gives rise to methane with the loss of carbon dioxide. This is requires higher temperature and a catalyst. As it requires very high temperature, the stringent reaction condition is required for decarboxylation. A easy method for this has been identified by Kolb's, and this is called as Kolb's electrolysis. We are taking the sodium and potassium salts of carboxylates, and this also has been used for the preparation of higher alkanes. Sodium acetate, if we take and hydrolyze it by electrolysis, we get higher alkane and sodium hydroxide along with the liberation of hydrogen and carbon dioxide. Electrolysis of sodium acetate, the acetate ions dissociate when we pass the electrical current in the solution of sodium acetate in water. This breaks to lose carbon dioxide and electron, giving rise to a methyl radical. The methyl radical, which is formed, two radicals combine together to form ethane. These are the major methods for preparation of alkanes that has been utilized. Every method has its own advantages and also it has its own limitations. Whether many methods are being utilized to overcome the limitation of the other. The alkanes can be prepared by reduction of alkenes, hydrolysis of Grignard's reagent, or by Wood's reaction, or by decarboxylation. Decarboxylation can be achieved by heating strongly thermally or by electrolysis. By thermolysis and electrolysis. Let us look into the other aspects of alkanes in the next presentation. Till then, have a nice day. Thank you.